Okay, here we are in chapter 3. The notes can be written in your student journal starting on page 63. And just to give you a heads up, we're going to do all 7 problems in this video. So the important idea for this lesson is determining whether relations are a function. So first you need to kind of know what a relation is. A relation, it pairs the inputs with the outputs. So when a relation is given as ordered pairs, the x-coordinates are the inputs and the y-coordinates are the outputs. A relation that pairs each input with exactly one output is a function. So this is really important right here. This is the key idea right here that we're talking about, because we're going to be determining if things are a function or not. You may notice, here is an example of a relation, and it is simply an ordered pair. This x-coordinate is known as the input. We have also called it by the name or referred to it as the domain, okay? The y-coordinate is the output, and we know that this is the range. So we'll be talking about all of these things in today's lesson. Okay, so to start, determine whether the relations are functions. When you do this, you want to double check and make sure that each input is paired with exactly one output. So for A, when we see, the inputs are -2, -1, 0, 1, and 2. Since the inputs are all distinctly different, there's no repeating of the inputs, then it would be a function. It says down here, right here, each input has exactly one output, so it's a function. Looking in part B, the inputs are 4, 8, 6, 4, and 5. I just repeated the input 4, meaning that 4 is paired with 0 and 4 is paired with 3. Right here, since the input 4 has 2 outputs, it is not a function. Okay? In C, we look at the inputs. We have -2, -1, 0, 0, 1, and 2. Since 0 is paired with 2 different outputs, 5 and 6, it's not a function. So what we're thinking about here, and the reason we're calling it not a function when it's paired with 2 different ones, what kind of mathematical rule can we have that if you input a value such as 0 or you input a value such as 4, that you would sometimes get a 5 and sometimes get a 6? Math doesn't work that way. So because of order of operations and everything like that, when you have a function and you substitute in a value for x, you will get the same y every single time. All right, looking at D, you have the inputs of -1, 3, and 11. Notice that they are different. You have, even though -1 goes to 4, 3 goes to 15, and 11 goes to 15, you can have different inputs going to the same output. You just can't have one input going to 2 different. So having arrows like this is okay. If I were to say do the diagram like this with my input values and my output values for part B, I have, I'll do it in least to greatest, 4, 5, 6, and 8. Okay, and my y values in least to greatest, 0, 2, 3, 4, and 7. And when I draw the arrows, I'm going to draw 1 to 0, 8 goes to 7, 6 goes to 4, 4 goes to 3, and 5 goes to 2. Notice right here, this situation where you have this 4 having 2 arrows being drawn to 2 different things, right? So that is letting you know that that is not a function, but having two different inputs going to the same output is okay. So for D, it is a function, okay? All right, let's keep going. The extra practice. We're going to determine whether or not the relation is a function. So what we're going to be looking at is on 1, we have -2, 0, 1, and -2. Since we have -2 going to two different outputs, it is not a function. Right? -2 is paired with 4 and 5. So it's more than one output for -2. All right, looking at number 2, 0, 1, 2, and 3, distinctly different inputs. So yes, it is a function. Because each input is paired with exactly one output, and that's the basic definition. Okay, moving on. The vertical line test. So luckily they drew the dashed line for you, but you could use your pencil. So if you took your pencil right now over the video and kind of like, you know, made it go vertically across, if at any time your pencil is touching 2 or more points, it can only touch 1 point at a time, then it, you know, if it's touching 2 or more, it would not be a function. So it says a graph represents a function when no vertical line passes through more than 1 point of the graph. So this first one, you know, it is a function because anytime if we were able to move this red dashed line left or right, it would only be touching 1 point at a time. For the sideways curved line called a parabola, the dashed line, the red line, you can see where it's touching a point here and it's touching a point here. It's touching with at least 2 points. So therefore it is not a function, okay? Let's take a look. So, looking at this, I guess if what you know you could do is maybe like try to draw your. I don't think I can. You know, okay, touching 1 point there, touching 1 point there, but right here it's touching 2 points. Okay, so technically we can say it fails the vertical line test. So it is not a function because the input value at that point is 2, right? Because input, the x value of 2 is paired with, you have 2 and 3 as outputs. So it's not a function. All right, looking at number 4. So, you know, this even goes not even on the lines, but look at every time I'm touching it, it's only 1 point, okay? So the vertical line test is successful at any time there's a vertical line. So this is a function. Because it passes the vertical line test. And what that means when it passes the test is that each input is paired with exactly one output. Okay. So finding the domain and the range of a function. So when we're looking at this and this whole concept of trying to determine if something is a function, I love the visual of the function machine, okay? So when you have a function, you put something in, the machine works, right? So say like it crunches the number, or it, does the math rule, which is the function rule, okay? And then it spits out a number. So you have your input value, your x, and you have your output value, your y. So another name for that, another name for the domain is all the x values, or all the input values. The range, all the y values. So we'll be talking a lot about when we describe a function, determining what the domain is and what the range is, okay? But think about the function machine and the reason why if I put in a -2 and sometimes I get a -6 and sometimes I get a 5, it's like, well, how could we write a mathematical rule because of the way the order of operations work that would make that even a possibility? You can't. So we call that not a function because we cannot write the function rule. So picture the function machine, and this is on page 62 of your student journal. All right, so now we're going to find the domain and range. So look at A, look at B. So on A, we have ordered pairs. So just list the ordered pairs for each point on the graph, okay? The input values, and you can kind of see it highlighted here, the input values then get listed right here as your domain. And we like to list them least to greatest. The output values are going to be the range, okay? Now we get to use in part B some of that compound inequality that we learned about, because this graph in part B has a definite beginning and ending, okay? So when you look at the input values, when you look at like what is the least value for your input value, it would be right here determined by this point, which is -2, -1, right? -2, -1. And then the highest value is determined by this point, which is at 3, 2. So the range of your x values, especially because these, on A, they're distinct points, but on B, it's a continual line. So it's every rational number. So it's, -1.5 and so forth. We could write the domain right here. So -2 is the smallest value of x. It's the smallest input. The solid line, or the solid circle, the solid circle at that point tells us that we need to use the less than or equal to. And so the -2 is less than or equal to x, which is, again, less than or equal to 3, and that's determined by the colored-in circles. The range then determines the height, like the change in the y. So the domain is kind of like the change in the x, and the range is the change in the y. Well, look at your y values. You have -1 and you have 2. So it goes between -1 and 2. So we write it as -1 less than or equal to y because we're talking about the output now. It's the range, which is less than or equal to 2. So we're going to get a chance to try some of those. All right. So in number 5, first thing I would do would be list the ordered pairs. So we start with 0, 4. Then we would have 1, 4. And then we have 2, 4. Okay. We have 3, 3. 4, 3. And 5, 3. Okay. So when we want to list the domain, we want to list all of these values, but there's no need to repeat any. There aren't any repetitions. So least to greatest would be 0, 1, 2, 3, 4, and 5. That's our domain. Those are all the x values. The domain is the input. Then when we list the output values, We have a 4, and a 4. Those are all the same. We have a 3, and a 3. Those are all the same. So our range has only 2 values. It could be 3 or 4. And again, we just like to list it in least to greatest value. Least to greatest order, I should say. Okay, so for number 6, sometimes if you identify the endpoints, so we have -3 and 3 over here. Okay, name the endpoints. And 3, 3. Then we can say our domain is going to go from -3 to 3, right? That's the range of the values on the x axis that those numbers inputs could be. So -3, and because of the solid circle here, right, is going to be less than or equal to x, because we're talking about a domain, or less than and equal to 3. Now our range is going to be the range of values on y. And so, you have your x that goes from here. Y, though, goes from here, all right? So the range at this point, at the lowest point, is 0. And because, it goes through it, it's included, so it could be equal to 0. So 0 is less than or equal to, now look what goes in the middle this time. Oops, the variable y. I didn't mean to make it like that. And that is less than or equal to the highest value of y on the y-axis, which is 3. So the range is from 0 to 3, and you want to write it as a compound and inequality, okay? Because we're talking about a range of numbers. Okay, so now we're going to begin to identify the independent and dependent variables. A lot of words here. I'm going to go ahead and read them for you. The variable that represents the input values of a function is the independent variable. It can be any value in the domain. The variable that represents the output value of a function is the dependent variable because it depends on the value that was input, or the independent variable. When an equation represents a function, the dependent variable is defined in terms of the independent. So the statement, y is a function of x, means that y varies depending on the value of x. So again, because the independent variable is the input, okay, and a lot of times when you think about in context of problems, and the dependent variable is the output because it depends on the x. When you think of the context of problems, the things that you are substituting in, like are counted quantities, right? It could be minutes, it could be any measure of time. It could be if you are, counting objects, things like that, depending on the number of objects. Lots of different things, but you always have to kind of look at it in the context of the problem and try to determine which one is independent and then which one is dependent. So number 7, we have a function. The function is y is equal to 12x. It represents the number y of pages of text a computer printer can print in x minutes, okay? So we want to identify the independent and dependent variable. Remember the independent is something that maybe could be counted, or it doesn't require anything else acting on it. So in this case, the x is the minutes. So independent variable is the x, that's the minutes. Dependent is y, and that is the number of pages printed, maybe. We'll kind of condense that, right? Okay, so if you have a domain of 1, 2, 3, and 4, what is the range? Well, let's make an XY table, an input-output table. You could do it horizontal, vertically. All right? So if we input 1, 2, 3, and 4, remember this is the function right here. And what that means is that it's basically printing 12 pages per minute, okay? So we would input the value of 1, so 12 times 1. Y is equal to like 12 times 1, which is equal to 12. So that's your output value. Y is equal to 12 times the input value changes to 2. The output value changes to 24. Okay? When the input value changes to 3, 12 times 3, the output is 36. The input is 4. 12 times 4, we have 48. So what is the range? 12, 24, 36, and 48. Okay, that concludes the notes for lesson 2.1.